Hello, today we have to study about flow control valve FCV. Flow control valve is mostly used to control the rate of flow of fluid, by which we can control the speed of actuator. There's many type of the flow control valve are available in the subject of oil, hydraulic and pneumatics. A flow control valve regulates the flow or pressure. All type of the flow control valve are regulate flow of liquid and pressure of fluid. Control valve normally respond to signal generated by independent device such as a flow meter, temperature gauge. Many types of the control are normally respond. It means that they are respond to control of flow, control of inside hydraulic line pressure are independent. They are not directly work because of there are not any control device are connected, so that itself cannot work, so that the all types of the flow control valve are independent. There we have to give the feedback from like as a flow meter or temperature gauge. We have to measure the flow of liquid and temperature of liquid. Then after we have to apply what should we have to do with the flow. Means we have to increasing flow or decreasing flow in the hydraulic line. What is the temperature about the working fluid in a hydraulic side. So the all types of the flow control valve are independent on hydraulic flow control valve. That's also known as a hydraulic flow control valve. Flow control valve are any device manufactured for the purpose of modifying the rate of fluid flow in a portion of hydraulic circuit. That's all types of the flow control are manufactured the purpose of modifying flow rate, means as per the requirement of the any hydraulic system that are not working on a single constant fluid flow, that's are vary with its working and hydraulic pressure. So it's necessary to that we have to control all time of the flow in a hydraulic circuit. Flow control valve can also work with a hydraulic actuator. Hydraulic actuator means that the single acting cylinder, double acting cylinder, as per the give the direction by the direction control valve. That's also work with that type of the valve. Also known as a hydraulic pilot. That type of the actuator called as a hydraulic pilot. This type of the valve are also known as a automatic control valve. Means that valve are operating by any another actuator, any flow meter, any temperature gauge is dependent. So that type of the valve also known as a control valve. In the previous video, we have to study pressure control valve PCV, and here we have to study about FCV, flow control valve. What is the difference between pressure control valve and flow control valve? In a pressure control valve, we have to maintain the pressure inside the hydraulic line. There is a many more of the pressure control valve are available, like as a pressure relief valve, pressure reducing valve, counterbalance valve, unloading valve, and sequence valve. The pressure relief valve used in a hydraulic and pneumatic systems also. They all types of the valve are control the pressure of the hydraulic system. And here flow control valve control the flow of liquid. If the flow rate of working fluid is more, then the cylinder will fill quickly, hence the piston will move faster. If the flow rate of the fluid is less, then the cylinder will fill slowly, and hence the piston moves slowly. Means that we have to require the fast work from the any hydraulic system for moving the load, like as a lift system or any downward system. That's we have to give the higher flow rate inside the system. If we have to move any lift system in a slow rate, then we have to give the flow rate in a less system. Here the difference in exactly how it sound. A pressure control valve PCV open and close based on the set point predetermined by the engineer. All types of the PCV, we have to set one pressure limit from the manufacturer side or design engineer. That time it's open or that time is maybe closed. That's usually control using a pressure transmitter PT. That's type all the pressure transmitter. We have to predefined set limit for a lower side and for higher side and work based on a pressure. The flow control valve FCV is exactly the same except it gets a signal from a flow transmitter. Here we have to attach a flow transmitter. Flow rate in the hydraulic line, maybe you have to consider in a liter form, liter 2 per minutes per hour. How many liter can pass from this line? That's we have to attach the flow transmitter and exact measurement we can gain. Then after we have to control the FCV, how many fluid we can to allow to pass inside the line. That's difference between a pressure control valve and flow control valve. The functions of pressure control valve. The first is a regulate the speed of the linear and rotary actuator. What is the actuator? The types of actuator we study in our previous lecture. If you to considering a single side acting cylinder, SAC, single acting cylinder. If you to require higher motion from the single acting cylinder, we can give the higher flow rate inside the cylinder. That's our work fast to piston move from its position to secondary position and regulate the flow. We have to also regulate the flow from inside to outside. Regulate the power available to the sub circuit by controlling the flow of them. In a hydraulic system, only one hydraulic pump and motor set are working there, and many more are operation we have to giving from this single side hydraulic pump. If you have to regulate the flow from a different working part that are required the FCV in each line, so we can vary the flow control. Proportionally divided or regulate the pump flow to various branches of the circuit as per one hydraulic motor pump set are working and many more work component are there. So it's a proportionally divide regulate the flow in every branch of circuit. That's the all the component part are work easily and smoothly. Here this is the normal check valve, means simple of flow control valve. I have to first say the how many types of the flow control valve are available. Fixed restriction FCV, FCV with reverse free flow, temperature compensate FCV, pressure compensate FCV, and temperature and pressure both are available. That pressure and temperature compensate FCV. Here this is the a symbol drawing. Here is a symbol of FCV. This arrow denoted this is the variable restriction FCV. We can vary or control the flow of working fluid. This portion are mentioned as a working fluid, means working flow path from this side to this side. Here is a flow adjustment screw. If you to require flow lower, medium or higher, we can adjust in a clockwise and anti-clockwise direction movement of the screw, and this area of opening we can manage from here. This is the area of opening we can manage from how many area we have to open and how many of working fluid can pass from this check valve. This adjacent screw means that we can vary the flow of control, so that here in a symbol we give a one arrow direction. It means there is a variable restriction FCV. This portion are as a body part of the FCV. This is the normal types of the FCV. Here the types of check valve. The first type is a needle valve. The first is a needle valve, second is a disc valve, and third is a gate valve. The symbol are same for that the all types of the check valve. You have to know about this construction side. This is the adjustable screw point. Can we have to move in a clockwise and anti-clockwise direction as per the requirement of flow fluid flowing from the check valve. This pink portion are known as a screw portion, where we have to movement give. This portion are is a inlet and this portion are a outlet for an all types of the check valve. Here this point are as a needle. This point are mentioned as a needle. Have to highlight in a some different color. These point are mentioned as a needle. And here is a sit point. Sit point means at this point this needle can attach with the seat and the close the portion and stop the fluid flowing from the check valve. Here this point are known as a inlet point and this point are as a outlet point. Here is a inlet point and here is a outlet point. If you have to move the screw in outward direction, the seat point and needle valve are increase the gap of between them, so the maximum fluid can pass from the portion. If you to move screw in a downward direction, this screw are move in a downward direction and is close the portion between seat and needle and close some spaces, means at this time the flow from the needle valve can decrease. If the seat are completely seat in this original position, that's time the flow cannot pass from the check valve. Means here the flow condition is completely stop condition in a check valve. The needle valve can as a throttle flow, means that type of the portion are also known as a throttling process. This area are mentioned as a nozzle type. The needle valve is can flow the throttle flow. Second is a disc valve. Disc valve is a known as also a globe valve. Is not suitable for a throttling process. Here is the spacing between the seat and needle is very large, so it's not suitable for throttling process. The last is a gate valve. Gate valve used as a on and off valve. This is the normal types of the bolt types valve. That's the one time is a close and second time is open. Not any throttling process occurs during the fluid flowing from the systems. The next is a flow control valve with an integral check valve or reverse free flow. This valve is used to control the flow rate in a one direction only. In other direction, the flow is not controlled. It is a free flow. Here we have to show that the flow from valve, you have to change the color from this point. Here the flow path from inlet to outlet is controlled by the adjusting screw, but in a reverse side we cannot control because of here we have the one check valve attached here. Thus flow are not controlled. It's depend on the back pressure of the hydraulic circuit. First we have to know all the component about that. This point is a adjustable screw. We can move in a clockwise and anti-clockwise direction for requirement of the flow control. And this portion is a screw which move from inside to outside in a FCV body. This denoted line as a body part of the FCV. This arrow direction mentioned that the flow path from flowing this point are as a in point and this point is a exit point. In point are directly connected to a hydraulic pump or any hydraulic working system, and these outlet point are connected to a hydraulic working system where we have to load and unload condition of the hydraulic circuit. Here the point A and point B that's are mentioned a reverse flow, means there is a one type of the check valve and it's give a one direction flow. Secondary direction it may be closed the force of spring. Here the spring is attached and here the small spool are attached. The flow of reverse is a opposite to a main flow. Here the flow of reverse is a opposite to a main flow. When the internal pressure of the hydraulic setup sets is goes to a increase, the flow is reversed to pass in a integral check and reverse free flow. That's time this higher pressurized fluid can press this spool and spring will be compressed. That the fluid flowing from B to A and compensate with the inlet flow where is coming from the hydraulic pump. Here the next drawing free flow are mentioned that the flow flowing from the hydraulic circuit as a higher pressurized which cannot flow from the its original position. Original position means that the flow flowing from the adjustable screw and its space. This is the free flow figure and here the restriction flow figure. The difference between the both figure is here the flow from the main restriction flow and the next figure drawing is mentioned the reverse free flow path from the check valve. Next is a balance FCV. The working component, this point is a fluid in and this point is a fluid out. This point is a plug 1 and plug 2. This is the spool, adjusting spool we can manage as a area of opening at the seat and plug. This point, this is the flow path from this seat and plug. If you have to move this spool in a upward direction, that's mean this spool also goes to up, and here the area of this spool and seat get increased, so maximum fluid can pass from this FCV valve. The both points are mentioned is a in and out to control. Here the two plug and two seat are available, so it's a balanced FCV, means it may be control the flow of working fluid. The next is a pressure compensate flow control valve. Here we view the some of the pressure bar are indicated in this drawing. First we have to understand about the components parts. This is the hydraulic symbol of pressure compensate flow control valve. This is the hydraulic symbol of pressure compensate flow control valve. These modules are as a externally work we can get from this. These points are mentioned as a in point where the hydraulic fluid enter from this side. Here when the pressure bar is attached, it's mentioned the how many pressure inside the hydraulic system. Here the secondary pressure gauge are attached, that outlet of the pressure compression flow control valve, how many pressure get from this FCV, and this drawing are mentioned that the FCV attached to a unloading valve. Simply we have to go for a working. That's all our component. Here is a one spring attached, that is a spool attached to give the flow path of the hydraulic oil. Here these point are as a entry point where the hydraulic fluid enter from this point. Then after the this fluid flowing from this way to this way. Then after this is the needle, we have to adjusting flow from inlet to outlet, how many flow we have to require for any hydraulic system, that we have to adjust from this adjustable screw. That is here maintain the area of opening and area of opening for this position. Then after we can control the fluid flow. Then after the fluid flow passed from this FCV point to adjustable screw, and then after this hydraulic fluid can exist from this point. But what is the meaning for pressure compensate valve? If the pressure is goes to a down, then the spool is move in a right hand side direction. The pressure is goes to a outside down, the spool is move in a right hand side direction. If the pressure of outlet position at FCV is increased, there is a back pressure generated in this line, and these pressure are directly affected to this spool, and spool move from left side to right side, and it adjusts the flow control. Sometimes this spool are in here this position, the spool is a this position. Then after we have to move its right side to left side, then after the spool is come at that point and close the inlet pressure. That means pressure component. If the pressure going to low down, the spool move right hand side direction. If the pressure at outlet are increased, whenever the back pressure is generated, the spool is moved from its right side to left side and close the inlet hydraulic pressure into the FCV. Means it's work on a pressure base and give the safety against the higher pressure at the working system on the hydraulic circuit. This is the temperature compensate flow control valve. First we have to understand about the component part. This portion are as a spring where the spring are attached. These two portion are as a spool working in a inside of the flow control valve. This portion are as a minor basis adjustable orifice piston, and backside is a temperature sensitive element. This dark side gray is as a body part of the flow control valve, and here this line is mentioned return oil from the line, and this also a return oil from the backside of the spool or piston. Compensator piston, both piston are working as a left and right hand side working. Now we have to check how it's work. This portion are as a entry point where the working fluid can enter from this point. Here the working or hydraulic fluid enter from this side. Then after the flow oil pass from this pass to here pass, and then after this pass and is exist from this pass. This is the working of FCV in a temperature compensate valve. If we have to consider in a first condition, the spool move from left side to right side. It means this area is decreasing and flow are also goes to a down in a hydraulic circuit. That's time the sum of the fluid is here, and some of the fluid is here. When the piston or compensator piston move in a right hand side direction, the oil is passed from this way to hydraulic circuit. When the secondary condition is that the piston move from right side to left side, the excess oil can pass from this way to a hydraulic circuit. But here the pressure for this position to this position are maintain a same pressure inside the flow control valve. Here this portion is called as a main regular flow. This arrow direction called as a main regular flow. If the temperature of hydraulic oil or any working fluid get increased, this temperature gauge are sense the temperature of the oil and its operate this spool piston or adjustable orifice. It's maintain the area of this adjustable orifice and gives the area of opening open or closed feedback condition. If the temperature is rise in a hydraulic fluid, this spool give the closed direction and close the area of orifice. These orifice are closed. This area orifice are closed. If the temperature of the hydraulic fluid is goes to a down, the area of orifice is goes to a open, so maximum fluid can pass from the flow control valve. If the temperature is higher as per the predefined or set limit, then this orifice area is closed and it may be down the working fluid in a hydraulic system. This symbol are mentioned. This line are black line is a hydraulic working line. This curve two curve line with arrow direction is mentioned a flow control valve with variable. This upward direction is mentioned a temperature compensate, and this arrow direction downward is mentioned as a pressure compensate hydraulic flow control valve. Okay, thank you.